In this series, I'll be monitoring CockroachDB. I'll be doing that using CockroachDB's inbuilt monitoring tools, as well as third-party monitoring tools like DBmarlin, Datadog, and AWS CloudWatch. Today we'll look at DBmarlin, which is a database monitoring tool that allows you to monitor a wide variety of databases, including, most interesting to me, CockroachDB. It provides second-by-second insights into what your databases are doing, and so helps you identify issues before they become disasters. Today I'll be using it to diagnose contention events in CockroachDB. My setup is quite simple. I have everything running in a Kubernetes cluster on my machine. We have two DBmarlin pods, a DBmarlin server and DBmarlin agent, and we have 3 CockroachDB pods. Let's configure DBmarlin to work against CockroachDB. Over in the DBmarlin console, I'll add a database instance to CockroachDB. I'll call it CRDB, although it could be called anything. My host address will be the FQDN for a private service against CockroachDB. The instance type is CockroachDB, although you can see that it supports a wide variety of databases. The port number will be 26257. I'll be just working against the default database and using the root user. This is an insecure cluster. And because I'm using contention events, I'll toggle the advanced mode and enable collect transaction contention. I'll save that and start the agent for the instance. Within a couple of seconds, you'll see that this goes green, indicating that the agent is up and running. Now that everything's up and running, I'll start a workload. This workload will generate very high contention. Essentially, it's a multi-threaded application that simulates bank account transfers between a very small number of bank accounts. In this case, I've got 4 workers that at every 10 millisecond interval will try to update 2 random accounts within a pool of 10 accounts. So we'd expect high contention. I'll start that workload. As a user of CockroachDB, you get access to the CockroachDB console, which contains a metrics page. We can see that the SQL statements have risen since we started the workload. And we can also see, if we scroll down, that there are contention events happening, multiple threads vying for the same data. I can use DBmarlin at this point to investigate the cause of that contention. Let's flick back over to DBmarlin and see what that looks like. We can see that there's activity already. And if I go to my CRDB instance, we're looking at data for the last 5 minutes. If my head wasn't in the way, you'd see more of that. But we also have this transaction contention tab. I'll click that and it shows where I'm seeing contention and the statements that were involved during that period. If I expand this, you'll see that we're running a bunch of statements per transaction. The first statement I run within my transaction block is a select for update, and I use that to check that I've got enough balance in the from account to make a transaction to the to account. And you can see that the blocking SQL array, that's the array of SQL statements that are in the contentious transaction, are the select for update and the update itself. And the thing that's waiting on that to complete is another select for update that's making a transaction from the same from account. This is all happening in the default DB, in the public schema, the account table, and the contended ID is the table's primary key. If this was on another index, you'd see this represented in the table. I'll now run an identical workload, but against a wider pool of accounts. And because we're working against a larger set of accounts, I would expect the contention to drop. Let's stop this one and start this one. I'll let that run for a couple of minutes and then we'll see what that looks like in DBmarlin. Having run the new workload for a couple of minutes, we can now see that the number of executions has gone right up. Because the workload is less contended, we're able to perform more transactions, and that's reflected in DBmarlin. You can see the sharp rise in the number of transactions that we've performed in around the same amount of time. Over in the transaction contention tab, we can see that while we are experiencing high contention in this period, that has definitely dropped off in this period. DBmarlin's time comparison is also a really nice way to see how your database is performing over time. Perhaps you've performed a database migration from one database to another. You can see how your application workloads are performing against each database. I'll do that with CockroachDB now, and we'll see how that new workload has affected things. These periods represent the block of time here and the block of time here, the point in time where my contention events dropped. Now there's a slight overlap here. This period is an overlap, but on the whole, you can see that generally the amount of time we're waiting has gone down, indicating there's less contention in our workload. That's the same for the top waits, the top statements. And if we drill into those transactions, we can see that the select for update is showing lower wait times, just as expected. If you're performing a migration of a database to CockroachDB, or perhaps performing version upgrades from one version of CockroachDB to another, DBmarlin's ability to perform snapshots and time comparisons gives you a really powerful way of seeing the implications of that migration. Give CockroachDB and DBmarlin for monitoring a try today and see how they can positively impact your workloads. You can give DBmarlin a try with a CockroachDB cluster entirely for free for 3 months. Check out this link for more information.